Good day, everyone. Now we will start the technical session 4 on severe weather. This session will be chaired by Air Vice Marshal, retired Professor Ajit Tyagi, Koteshwaram Professor and Permanent Representative of India with WMO, Ministry of Arts Sciences. The co-chair of the session is Mr. Rahanul Haq Khan, Bangladesh Country Program Lead at RIMES. I'd like to request session chair and co-chair to start and conduct the session. Before starting the session, I'd like to request Honorable Chair and co-chair to evaluate all presenters according to the prescribed format and send us as soon as possible. Thank you all.
Very good evening. Namaskar, day of this international conference on meteorology and climate sciences being organized by Department of Meteorology of University of Dhaka. And at the outset, let me compliment Professor Tawhida Rashid and her team for having put together 2 days workshop and seminar, a truly international conference, bringing researchers, academicians, young scientists, operational meteorologists together on a single platform to address issues related to the meteorology and climate sciences focused on the South Asia. I'm really consider myself honored and feel happy to be chairing this session, which deals with the severe weather, along with my co-chair, Dr. Rahanul Haq Khan Sahib. It's a pleasure to be associated with it. Personally, as you know, particularly I've been following the first 2 sessions. It's a wonderful mix of senior people presenting here from the international domain, also from the regional domain, experts, and also the young researchers. So for them, experience as well as presenting their work and getting feedback. So it's a really a very good initiative by the University of Dhaka. And we have a very good regional participation and also international participation, including a training workshop supported by the COMET. So it's really a very good initiative. I wish it great success, and I'm sure it should be followed by many such conferences and workshops in the region. We in South Asia have started the South Asian Meteorological Association to promote regional cooperation. It's more of a knowledge platform, and it's just started this year during the COVID period. And we are receiving very good response. We have done a couple of events, which very good participation from the young students and the researchers. And one of these events is going to be tomorrow also on atmospheric observations. So these are good initiatives where the researchers and the young researchers are participating. In this session, there are 4 presentations covering different aspects of the severe weather, which affects South Asia, tropical cyclone and heavy rainfall, strong surge, lightning, and the floods which are there, of course. So I am happy that all these 4 aspects are going to be covered, and we have a mix of senior researchers from Kyoto, Professor Takumi, and younger researchers from the universities in Bangladesh. So with these opening remarks, I request my co-chair to share his views before we request our first presentations as given is going to be for 15 minutes, of which first 12 to 13 minutes will be by presenter and 2 to 3 minutes for the question and answer session. So I request all distinguished presenters to keep this in mind so that we can have a question and answer session. And so may I request my co-chair, Haq Sahib, to share his.
Thank you very much, Ajit Tyagi sir. I'm very delighted to be here today, co-chairing with you. And I will not take much of the time. I'm very much looking forward to the presentation because these 4 papers that we are going to look at today it is a very contextualized for forecasting of severe weather in Bangladesh. And as for my organization, Regional Integrated Multi-Hazard Early Warning System, RIMES, we work with the National Hydromet service providers in the region, including Bangladesh Meteorological Department. So I'm very excited to see how this research can contribute in operational meteorology and forecasting. So thank you very much. That's all from my end. Over to you, Ajit Tyagi sir.
Okay, thank you. Well, request our first TPRI Kyoto, a vast experience in academic and research field, and he's to deal with the important topic, historical as well as under the various climate projection scenarios scaled for the South Asian region. Focus on cyclones and the heavy rainfall. So now the floor is of Professor Takumi. Please go ahead and make your presentation.
Hello, I'm Tetsuya Takemi. Can you hear me? Okay.
Yes.
Okay, thank you. Thank you, Chair.
Please go ahead. Sure.
Okay. Thank you for inviting me to join this conference. I'm very pleased to be part of this conference. Today, I'm going to talk about assessing the impacts of climate change on extreme weather. I will focus on downscaling experiments. This is the talk I would first how to assess meteorological hazard under climate change. Hazard can be assessed by considering worst class scenario. Past in sensing hazard scenario, past disaster responding cases are regarded as a baseline for the hazard assessment. Downscaling experiment with the regional numerical weather prediction model are vital for quantitatively representing convective scale processes and topographic effects. And in order to assess the impacts of climate change, effective use of climate prediction experiments is important. So high-resolution global climate model data are used for downscaling. And in our study, we employ a pseudo-global warming experiments for worst-case tropical cyclone under global warming. Sorry. And how to assess the impacts of climate change on typhoons and heavy rainfall? We employ a pseudo-global warming experiment. Pseudo-global warming experiment is a method to examine the impacts, quantitatively estimate the impacts of climate change on a specific world-class weather phenomenon. In defining PGW conditions, we first use the actual condition obtained from reanalysis dataset, such as JERA55. It's a Japanese long-term reanalysis dataset, which is available from 1958. So we use this kind of reanalysis dataset to define meteorological conditions for a specific case. In order to consider the global warming impacts, we define global warming increment, which is defined as the increment from GCM future climate minus GCM present climate. Using the GCM products, we define the warming increments for temperature, pressure, sea surface temperature, etc. And add such global warming increments to past analysis field. So pseudo-global warming climate state is defined as the sum of reanalysis field plus monthly mean global warming increment. So we use a climate prediction dataset from Japan Meteorological Agency's Meteorological Research Institute, high resolution global circulation model outputs, 20-kilometer resolution dataset. And present climate is defined as a period from 1979 to 2003, and future climate is defined as 25 years at the end of this century under RCP 8.5 scenario. So let me explain about the PGW experiments for tropical cyclone. We examined a case study for extreme rainfall by slowly moving typhoon Talas, which occurred in September 2011 over Japan. And we use JERA55, a long-term reanalysis dataset, to define the past meteorological field for September 2011. And we add global warming increments to JERA55 analysis field to create a PGW climate condition. I'm showing on the left the tracks and intensity of the simulated typhoon. We have run an ensemble of the experiments, which I have changed some of the parameters in regional model. By the way, we use the weather research and forecasting model, WRF model, to do dynamical downscaling. On the right, I'm showing the track and intensity of this specific storm under future climate condition. So this is the rainfall produced by Typhoon Talas in 2011. By this specific storm, there is a total amount of rainfall exceeding 2,000 millimeters over a part of the Japan, southern part of Japan. The rainfall extended for 5-day period. and produce the extreme rainfall. Like this, like that's shown in this panel. We conducted a dynamical downscaling for this typhoon and by changing model parameters. In the upper two panels show the results for dynamical downscaling under the present climate condition, September 2011 condition, by two different model parameters. In the lower panel, show the results obtained from PGW experiment, and the figures indicate the total amount of rainfall during the passage of the typhoon. You can see that there's extreme rainfall over this region, and in some part, the total amount of rainfall exceeds 2,000 millimeters, which corresponds well with the observed rainfall. With the PGW conditions, you can see that the increase in the total amount of rainfall in some region. So the impact of climate change appears on the total amount of rainfall. And this figure shows the cumulative frequency distribution of total rainfall. In the upper panel shows the cumulative frequency distribution of total rainfall for present climate condition indicated by solid lines, and period of climate conditions by dashed lines. So pristable water, total amount of rainfall increases specifically in the extreme values. For example, 99.5 percentiles. And in the lower panel shows the different environmental conditions in terms of pristable water and temperature lapse rate. So under future climate, pristable water increases in spite of the decrease in temperature lapse rate. So in terms of the environmental conditions, the increase in pristable water vapor, which sometimes exceeds 80 millimeter, which would never occur under present climate conditions. So this increase in pristable water plays a critical role in intensification of tropical cyclone and the resulting amount of rainfall. We have also do further downscaling to urban scales, and this is another case study for severe winds occurred in Osaka City, Japan during Typhoon Jebi in 2018, 2 years ago. By this typhoon, there were severe damages in urban districts, like that's shown in these pictures. And in Osaka City, the maximum wind gust is about 47 meters per second, which is the third record during the recorded history. And this typhoon is a Category 5 storm. So first we use the WARP model to do a dynamical downscaling up to 0.9 kilometer resolutions. And for the city scale, urban scale, we use a CFD model with a large eddy simulation technique. to downscaling to 2-meter grid spacing. We use the building data set for the urban districts. And on the right, I'm showing the height of the building, individual buildings. So actual building distribution are represented in the large area simulation model. And we assume a southerly wind produced by the typhoon, and we simulate the airflow within the urban canopy layer. And on the lower right panel, I'm showing the distribution, horizontal distribution of the maximum wind speed, instantaneous wind speed. And strongest winds appears around the high-rise building or densely distributed uh, building clusters. And also along major street avenues, maximum wind gust is stronger compared with the surrounding region. And using the large area simulation model, we can reproduce the turbulent or fluctuating nature of airflows within urban districts. In the lower left panel, I'm showing the time sequences of the fluctuating wind speed in the urban districts. In general, strongest winds appears around the high-rise building and open spaces. So we are doing a dynamical downscaling technique to assess the impact of climate change by downscaling from regional scale, city scale, and district scale. With this dynamical downscale, we can quantitatively estimate the extreme rainfall or windstorms. This kind of quantitative evaluation can be used for climate change adaptation and mitigation strategy. And then we are now collaborating with the policymakers to implement our dynamical downscaling technique. So hazard assessment, impact assessment, and adaptation mitigation will collaboration among these three leads to or help the policymakers to tackle with the climate change. So this is the summary of my talk. We use the dynamical downscaling PGW experiments to examine the impact of climate change on extreme weather. In this presentation, I will focus on the extreme rainfall event produced by Typhoon Talas in 2011. And we are also doing resolving large area simulations of airflows in urban districts. We have introduced the case study for Typhoon JB. And stronger winds appear around high-rise buildings and along major streets. Okay, and thank you. That's all I have. Thank you for your attention.
Thank you, Professor Takemi, for a good example of downscaling and winds and rainfall, especially rainfall you have shown with the two typhoons. I'm sure this approach in our South Asia also, because ultimately prepare for the see whether strong
I'd like to request Honorable Co-Chair to conduct the session until our Honorable Chair has been come. Thank you.
So I think we can move to the next presentation. I think, sir, Ajit Tyagi, sir, can you hear us? Okay, so I would now like to request Mr. Abul Kalam Mullik from Bangladesh Meteorological Department to deliver his presentation on lightning potential index parameter for predicting northwesterly storms, its associated rainfall over Bangladesh using WRF model.
Respected Ajit Tyagi sir, I know him very much because we met him in Korea 2016, and also respected Ryanul Haq, co-chair of the session, and also the participants. Assalamu alaikum and good evening. Am I audible? Rahan bhai?
Yes, we can hear you loud and clear.
Okay, thank you. So my title already.
Please go ahead.
Outline of my presentation is the why I did this research actually. That means the motivation and objectives, and introduction and general review of the research, model setup, result, and discussion. Motivation is like that. Every year, thunderstorms occurs in Bangladesh, and due to lightning strike, many fatalities occurred every year. Globally, you know that from the source of Ronald Holle, he found that from 1990 to 2017, the fatality and injuries is shown due to the lightning strike. And we know that every year, 3 million lightning strikes occur, and it is mentioned in the cloud dynamics in the house. And also, if we compare that and observe that 1990 to 1999, 30 deaths and 22 injuries per year. This data has been collected from the printing media Bangladesh. And also 2000 to 2009, we found that 106 deaths due to the lightning strike. And also to 2017, we found that 2060 deaths and 211 injuries per year. So from 1990 to 2017, we found that the death total number of deaths is increasing due to the lightning strikes. And so it is also a hazard, and Bangladesh government also declared this is a disaster actually. So before the research, I have reviewed some things what happens due to the lightning strike. So we can found that Dewan Akel 2017 in his paper told that this on, and also sorry, Land and Yard 2009 and other associates announcement and operation of the lightning potential index, a new index for estimating the potential for lightning activity from weather forecast model output data, and the reference is here mentioned. And also, George 1960, very beginning, told that K index was used to predict the lightning introduction, assuming every thunderstorm is accompanied with the lightning. And also, Williams et al. Also mentioned that K is very responsible for the lightning activity. And also, the Cape and cloud physics thunder parameter values can be the optimal estimators of the areas that are prone to the lightning activity. It is mentioned in the right and associated, published in 2005. Also, reason I find that lightning strike can be a tool for forecasting of the northwesterly storm. And here at all, in 2010, mentioned that lightning potential index is the measure of the charge generation and separation in the clouds. They show that there is positive correlation between the observed number of lightning area, then area density and heavy rainfall. And many other scientists also done that lightning potential index is also related to the values, in values, total index, lifted index, cloud physics standard parameter, and they mentioned that this thermodynamic parameters is very useful for predicting the lightning index. So that earlier I mentioned that year at all in 2010 has calculated the lightning potential index and field in numerical weather prediction models. So in weather research and forecasting model, we can simulate this lightning potential index because with the prediction of the lightning potential index, we can easily say severe thunderstorms area and its associated lightning flash and its lightning flashes. Now, my objective of the research is that to compare and validate the WL model simulated Cape, total index, wind speed with the observations, and to determine the mixing ratios of different hydrometeors like ice and groupel, and relate it with the precondition of thunderstorms and lightning, and also to calculate the electric field and associate it with the discharge of lightning. Then we have calculated the lightning potential index and relate it with the occurrence of thunderstorms. So we know that it is very, know that now we want to have that during the droplet accretion or rhyming and ice crystal rebounding collisions here, the charging groupal particle is liable for the charge separation. And we found that the triple charge distribution is occurred in a certain region where temperature is -20 to -40, and we found that three charge is formed in the groupal charge negatively at the low temperature and positively at the higher temperature actually. So it is very important for calculating the lightning potential index. And now we know that charge zone occurred actually rough. It is mentioned in the cloud dynamics of house that charging zone is 0 degrees Celsius to 20 degrees Celsius. So there happened non-inductive ice groupal mechanism, which is also responsible for charge separation, and that's why we have to. But it does not calculate the resultant electric field or its evolution. So it is also important. Now we come to my research theme, that lightning potential index. We can calculate the lightning potential index actually by these equation. This equation is very important for calculating the lightning potential index. That is, we found that we have to calculate first from the mixing ratio of different ice fraction mixing ratio, sono mixing ratio, and also the groupal mixing ratio. We can calculate the scaling factor epsilon, and also we can calculate the mixing ratio. So if we calculate these scaling factor of the cloud updraft, then using these equation we put the value of the epsilon and also um, a vertical wind component in meter per second. If we put, then we can calculate the lightning potential index. And this lightning potential index is very much responsible for lightning flashes. So we can go further that and also we have to calculate the electric field. That is nothing but the calculation of the charge density and also the epsilon naught, which is an electric constant, so that we can calculate the lightning potential index and electric field in the charging zone using these equations. For this reason, at last you know the Poisson's equations, and using these equation, electric field and the constant factor, and putting these values, density of group L and ice, we can calculate the del dot E. Now in the research we have calculated the K value. We know that equation is this, and also we calculate the K index and also total. So we in this research we have using the microphysics WF single moment 6 class scheme, because there are 6 components which maybe changes their states, which is covered by the microphysics, and also the cumulus physics. We have used the Kenfield schemes, which is related to the deep and shallow convection. So this microphysics schemes and also the Kenfield schemes is used in my research. So now we have calculate the lightning potential index of 2 events. One is 25th April 2018, and another is 11 May 2018. First event was occurred in Dhaka, and second occurred in Khulna. And my study is that this mother domain. We focus in my research for this presentation only the finest domain, the small. This one is shown later. And this is the WF model setup. Earlier I have said that this resolution is 9 kilometer, 3 kilometer, and 1 kilometer, and vertical corridor 35 sigma levels. And we have used earlier, we said that cumulus physics and practice and WF single moment 6 class scheme for microphysics, and data is used for FNL data for this study. Result and discussion. I have to calculate value, and we know the Rajavan at L 2002 published that the threshold value of the K value for the severe thunderstorm in our Indian subcontinent actually 2000. So I have considered this value for the predicting of the K value here. But in the observed swimming universe, we found for the first event that over Dhaka we found this value is 1356. It is not too close, but reasonably well. And we have also Khulna, we have found the convective available potential energy is 1800 joule per kg, which is also very close to the threshold value. And also we calculate the total index over Dhaka for event 1, and we found this one is very this increasing 00 UTC to 18 UTC. The event occurred, so that time the value of total index was nearly 48 or 50. And also we have calculated that total index also for event 2 for Khulna, it is also reasonably well to the threshold. So distribution of upper and lower level wind flow, both events we have calculated that there was a westerly is supporting westerly here also. Gusty winds occurred in Dhaka, also Dhaka, and after 9 UTC, it is started to reduce. So we have found that wind speed were 2.55 meter per second and 88.2 meters per second for event 1 and for event 2. So we found that, and we calculate the particle of jet component of the velocity of event 1 and 2 also, and we find that the velocity greater than 0.5 meter per second for event 1 and also for event 2, which is very reasonably well. And also we have calculated the vertical profile of ice and group L mixing ratio, because earlier I have said that ice and group L at the time of accretion and rhyming, it is responsible for the formation of lightning flashes. Then we have put these values, electric field and also the epsilon to the lightning potential equation, and we have calculated the lightning potential index actually. So we have considered in my research level these threshold value actually, these one. So we have found our value 0.012, 0.001, and somewhere we have found the lightning potential is more than 0.01, which is the threat level. So WF Market simulate the lightning potential index very well, and which is consistent to the linear toll observations. Excuse me?
Dr. Malik, you got another last 2 minutes to conclude.
Okay, I should cover, sir. Then I have calculated the vertical component of electric field of event 1 and 2 actually, and we found the electric field is decreasing like this way. And have you any question? Then please, for the time, you can write in my chat box and I will discuss later. And we have find like this electric field. And from the from the research, I have found that Kf is greater than 2000 large convectivity is present 10 hours before the events actually. That is responsible for the lightning potential entrance. Also, total index is also greater than 45 degrees Celsius, which is lead to the formation of thunderstorms more than 10 hours prior to the event, because I have found at the before the thunderstorm start 10 hours prior of the event starts, the total index value is greater than actually. Dry and cool upper level air and warm and moist lower air is found earlier on the event. And also, Z component is very important for the calculation of the lightning potential extent, and it is found that 0.5 meter per second. And also, a lightning potential index, then threat level value, then 3 hours before we have calculated the electric field, also 100 kilovolt per meter of mid-tropospheric region, that means in the charge region on or before. Thus, all the parameters we analyzed could accurately predict the thunderstorm and lightning. So, I think our goal is to observe the calamities of the past few decades and demonstrative extensive study on the effects of the parameter of the thunderstorms and lightning, and for the South Asian region at the time. And also both the regions selected in our current study are mostly plain land, but the study of the hilly side and South Asian region remains unfocused. In our further studies, we wish to explore our lightning activities over hillside regions in Bangladesh, Sri Lanka, Nepal, Bhutan, etc. So our study is done only for 2 thunderstorm events actually by using the ERATL equation, but we cannot perform more events and eventually in the best prediction of techniques for the thunderstorms more accurately. So we have to study more and more. Thank you very much. This is the last slide. So, respected chair and co-chair, have you any question?
Well, Dr. Malik, I'm sure you have done a very good study, though limited to the 2 case studies, but it holds a great potential for application. And since Bangladesh and adjoining region is prone to severe thunderstorms and lightning deaths, which you have shown that is increasing over a period of time, it's very much required that these studies further extended for more cases and validated. So I'm sure it's a very good beginning, and I request participants to ask questions on this interesting topic, because it is a very important operational requirement of the region, predicting thunderstorms and the associated lightning. So House is open for the questions from the participants.
Can I ask a question?
Yeah, please.
Yes.
Yeah. Maulik sir, it was an amazing presentation. I should appreciate that. But I have a little query, that is there any way to evaluate the performance of the lightning potential index? Actually, how we can calculate the skill of this system or algorithm? I mean, how we can analyze the performance of the lightning potential index?
Okay. Yeah. Thank you very much. Actually, we have a algorithm which is written in the Fortran actually, and or in the MATLAB. Using MATLAB, you can also make a algorithm because you have to calculate the lightning potential by using that algorithm. You cannot directly calculate the lightning potential index using the WF model. You have to define some things. You have to define the cloud charging region, then area average cloud region, and also you have to calculate the electric field actually, so that then you have to calculate the mixing ratio of group L and ice, which is very responsible for the formation of the lightning flashes. So group L mixing ratio and ice ratio, it can be calculated by the WF model, but the scaling factor you cannot. So that you have to make a algorithm we have made. If you need, then please come to BMD and I will give you the algorithm. And using that algorithm, you can easily predict the lightning potential index. But skill calculation is different, because you have to calculate the lightning potential skill through some sophisticated verification method actually. So without verification, you cannot calculate the lightning skill of the lightning predictability of lightning potential index. So you have to test some skill score test, and doing some skill score test, you can verify the skills of the lightning potential index. Thank you.
Thank you, sir. So actually, I have a question for Professor Takemi. Can I ask it now, or I can ask later?
Yeah, you can ask me now.
Yeah. Actually, are the large AD simulation model open sourced? And which type of data are used in this model? Can we use the direct output of the WRF in this model?
The large simulation model is made by ourselves, so it's not the open source. Yeah, but if you're interested, we can provide the source code.
Okay, sir.
And also, currently, we do not directly couple the WRF to LES. We assume the WRF wind speed to quantify the wind speed simulated by LES. In LES, wind speeds are normalized by wind speed at the boundary layer top. So LAS generates wind speed, normalized wind speed. So and the quantification is obtained from WRF results. So we use the WRF outputs to estimate the wind speed at the boundary layer boundary layer top. For example, if the WRF winds produce 70 meter per second at the boundary layer top, then we can quantify the LES wind speed. So LES can be run without the outputs of WRF.
Oh,
Yeah.
thank you, sir. Thank you, sir.
Okay.
I have got a question for Dr. Malik. This is regarding the verification. I understand now there are Earth network and many other lightning networks which are there. So we should be able to get this data of lightning happening, say, within closest to your predicted time in a given area. And they give a fairly good idea about the lightning taking place, lightning flashes per minute, per hour, and the severity of the lightning flashes also. So I'm sure you should try to use that data for verification of your lightning potential index, because that is very important. Giving lead time of 10 hours for the thunderstorm to occur and 3 hours if you can give of lightning protection, it can be very much useful for safety measures. So please look into it.
Okay, thank you. Sir, I have already studied your paper, which is related to you have calculated the different thermodynamic parameters for thunderstorms, and you have mentioned some threshold values actually. It is also a good paper, sir. I studied. Thank you, sir.
Thank you. Yeah, but all this needs to be validated for a given region. That is very much important. Thresholds, and I'm sure you are doing a good work, so it needs to be further extended. Thank you so much.
Thank you, sir.
Now we move into the next paper. Haksab, can you request the next speaker to make his presentation?
Our next speaker is Mr. Akhtar. I would request to deliver his presentation on extreme temperature condition and construction of comfort index over Bangladesh. I think this is a new kind of study, and it might be very interesting for us.
Thank you for giving me opportunity. Can you hear me?
Yes, please.
Okay. Okay, I am Dr. Akhtar, and my co-author is Dr. Abul Kalam Mullik. The title of my presentation is Extreme Temperature Condition and Construction Component Breaks over Bangladesh using NWP models. At a glance, the presentation, first I will say the motivation, which thing motivate me or encourage me to do this research. Secondly, what is the objective or target of my research, and some definition or category of the heat wave. Then the methodology and models and package I use for this calculation. Next, result discussion, conclusion, and some future plan. First, the motivation. A large number of people die every year because of heat stroke and heat exhaustion caused by heat wave. It is published 2014, author is K.R. Smith. Another newspaper, June 3, 2007, in Bangladesh newspaper, there's 25 people die and nearly 2,000 people injured in Bangladesh because of this heat wave. Another international journal of environmental science, 184 people has died in Bihar and dozen in other states in 2019. Another news, a heat wave has killed 65 people in Pakistan's southern city of Karachi in 2018. 35% people die as a result of record heat wave that scored Europe in August 2003. This is according to Ray et al. 2003 and published in Health Report. This is a picture for development model, and as you know, the HIST RCP 4.5, RCP 8.5, published in Geospatial World on 27 September 2017, that Indian subcontinent may become too hot for human survival in the next 80 years. From this 3 planet, we can see there's this area, there is Indian subcontinent, is the hottest area among the others places. Another that is published in Science Journal, Science Advances, India, Pakistan, and Bangladesh would become too hot for human habitation by the year 2100. This study has been published in the journal Science Advances. This is some scenery that in this 4 picture we can understand that there is a impact of heat wave. This one 3 August 2017 at Dhaka. This one 27 May 2019 at Khulna, Bangladesh. And this one is also Dhaka 23rd April 2019. And this is New South Wales, Australia, 19 December 2019. In this figure, we saw the rickshaw puller is exhausted because of heat wave. This is also impact of heat wave in Bangladesh. This is India, heat wave killed 200 people. This is a bird is seeking water. This picture is from Japan, heat wave killed 14 in 2018. This figure shows that July 2019 was the hottest month on the record. This symbol means the extreme temperature. So we can see from here very clearly that Alaska, Europe, Bahrain, Asia, Hong Kong, Israel, South Africa, Hawaii, all of here are the very hot places in July 2019. This figure is according to National Oceanic and Atmospheric Administration, NOAA. This is a global average temperature. This is we understand that this is a zigzag up and down, but from here, this is increasing. This figure is up to 2020. So global average temperature is increasing. There is a 2 graph here. One is the annual meaning and another is 5-year smoothing. This one is 5-year smoothing. So from this figure, it is very easy to understand that temperature is increasing. This is something heat index according to NOAA National Weather Service. From this data, we can easily understand that if temperature is 27 and relative humidity is 40%, then we feel temperature is 27. But if humidity increase, then the feeling temperature is also increases. And this color is caution, that is uncomfortable for the man health. And this color shows extremely caution, and this color is danger, and this color is extremely danger. So it is very clear from this data that if humidity increase in the same temperature, the temperature will be uncomfortable if the relative humidity increase. Now, the objective of the research, I should first say that I used WRF model for calculation of some input data, and then I use Raman model for calculation of our component index. But which physics will be best? For this reason, I perform some PBL and SL scheme, planetary boundary layer and surface layer scheme. Which one will be better? So to investigate the performance of PBL CL scheme to produce initial meteorological variable to compute comfort index. Next, making the best PBL and SL, I change the land surface model, which one would be best, and then finally I calculate the comfort index, that is physiological equivalent temperature. Now, this is the definition I use in my research. The heat wave is defined as a period of successive hot weather, which is accompanied by high humidity and which subsists at least 3 consecutive days. But according to World Meteorological Organization, a heat wave is 5 or more consecutive days of prolonged heat in which the daily maximum temperature is higher than the average maximum temperature by 5 degrees Celsius. According to BMB, temperature equal or greater than 36 degrees Celsius is defined as heat wave, but in our research, temperature, we define heat waves as a period of successive hot weather which is accompanied by high humidity and which subsists at least 3 consecutive days. Now this is the category according to BMD based on temperature. 36 to 38 degrees Celsius is called mild heat waves, and 38 to 40 it is moderate heat wave, and 40 to 42 it is a severe heat wave, and greater than 42 it is a very severe heat wave. Because of the influence of relative humidity, as we have already seen, because of this relative humidity, wind speed, and cloud fraction and solar radiation, human body feels temperature greater or lesser than air temperature. The temperature which feel in human body is called physiological equivalent temperature, PET. Now it's known as the comfort index. People of different age feel different PET because of their skin condition and energy production rate. The methodology I use here, at first we calculate the percentage 90% days, and that is must be greater than the threshold warm days. And I use W model for heat wave simulation, and I did some sensitivity test, who is PBL, who is land surface, and who is surface layer will be best fit. And finally, Raymond model is used for physiological equivalent temperature, that is PET, and which is also known as comfort index. In this case, I consider 2 events. One event station is Rajshahi and another is Khulna. And first one, it was 7 days run from 00 UTC of 18 May to 21st UTC of 25th May. That was in 2015. And second event also same year, but it is different time, 0 UTC of 5 April to 21 UTC 8 April. This is the W model setup. Data use is global forecasting system, GFS. We consider 2 domains, and this is the resolution 9 kilometer and 3 kilometer. And cumulus physics, microphysics, and PBL, we consider 3. Winslow University scheme, Miller image sensing, asymmetric convective model, version 2, short wave, long wave, surface layer, MM5 similarity, ETA geotropical scheme, and NOAA MP scheme, NOAA scheme, and REFIT update model, and also cloud local non-local. There is a simple description of the physics scheme. I think everybody knows all of these things. So I would like to skip this one for time's constraint. And this is something, the planetary boundary layer interaction, and just, I think everybody knows this. So I will skip this one also. And this is the sensitivity test. Here I use 4R, 1, 2, 3, 4, up to this, to keep this land surface model constant, same thing. And at first, I consider who is PBL up to this 3 and who is land surface will be best fit. Then I understand that this one, NSU, PBL, and MM5 land surface is best. Then using this constant, I alter NOAA MP, CLM4, RUC, Lancer Mosen, and which one is best to understand. And finally, we'll see that this combination gives the more error compared to observe. So I'll calculate PET using this parameterization scheme.
Dr. Akhtar, it would be
Yes.
good if you could complete the presentation within a couple of minutes.
How many minutes?
In 2 minutes.
Okay. This is the governing equation. I will skip with this one. This is the Raman models. We have to input the air temperature, vapor pressure, relative humidity, and something is defaults here. And this is the input, humidity, wind speed, RMT, temperature, cloud cover, and Raman model will give us the PET. This is the result discussion. At first, we calculate temperature of event 1. In this case, we'll PBLSL and we have to observe. And this is a zigzag, we cannot understand which one is the best. And here also, we cannot understand which one is the best. Then we, this is for event 2, and then we calculate the statistical simulation of temperature. And in this case, we understand which one is better because it gives the root mean square error. And this is samely for wind speed for event 1, and this wind speed for event 2, and this is his statistical simulation. And this is relative humidity for event 1, this is relative humidity event 2, and this is statistical simulation relative humidity. And this is a calculation, this is a standard difference range of thermal comfort. This is well known to everybody. And this is a calculation of PET, variation PBL scheme for this. And this for event 2. And this is RMS values. And this is the scenery that I would say something that this one is best, and this one for this is the best one. And using this, we calculate finally the PET. And this is for Rajshahi station. In this case, it is very clear that PET is greater or lesser than air temperature. PET is actually which feel in human body, so-called comfort index. And this is for our another event. And in this case also, PET is greater or lesser. And the conclusion is that W model performance is well enough to produce observed temperature, relative humidity, PET values in the YSMF scenario compared to other combination. W performance is very well to predict T2 and PET values in NOAA land surface model phases compared to other. Meteorology department of Bangladesh of different countries predict air temperature as well as feel like temperature. So predict comfort index, BMD can use YSOMM5, PBLSM scheme, and NOAA lens initially, but need more studies. And this is the future prospect. Our study investigate only 2 stations because of computation constraint. In future, we can study by increasing number of stations for more confidence. More case studies may give better result for the prediction of comfort index. Thank you very much for your patience.
Thank you, Dr. Akhtar.
We can't hear you, Tegi sir.
Hello.
Yes, yes, now it's here. I think
There is the echo. Haksab, you can take over.
Thank you very much, Dr. Akhtar, for your presentation. I think as this involves, I think considering the comfort index for Bangladesh is a new thing because Bangladesh Meteorological Department is not currently providing such information. Certainly, this is a good initiative for research. But I think similarly, for the previous presentation, we need more cases to validate it. And as it involves physiological feeling, so I think we might also need to consider the experiences of people and validate in different regions of the country. And that way, I think we would be more confident to conclude with the comfort index. I think we can move to the next presentation, and if we have any question from the audience, we can take after the last presentation. So I would now request our last presenter, Mr. Faisal, to deliver his presentation on the simulation of storm surges in Bangladesh using numerical weather prediction models.
Thank you to our respected chair and co-chair, sir, for giving me the opportunity. Good day, everyone. You are all enjoying this wonderful conference. I am Kazi Asif Faisal. I am an MSc student of Department of Meteorology, University of Dhaka, Bangladesh. The title of my research is Simulation of Storm Surges in Bangladesh using NWP. Now, storm surges is one of the most devastating natural disasters and usually accompanied by devastating cyclones. However, many times storm surges cause more damage and destruction than the cyclone. The coastal region of Bangladesh is particularly vulnerable to cyclonic storm surge floods due to mainly three reasons. They are its location in the path of tropical cyclones, wide and shallow continental shelf, and the funneling shape of the coast. So there is a great necessity to be able to properly predict and forecast storm surge, which will help in management and early warning of an upcoming storm surge and reduction and control of the negative effects. Objectives of the study are simulation of significant storm surge events in Bangladesh using NWP models, and then comparison of the simulated results of significant storm surge events for more accurate prediction of storm surge. For data and methodology, to simulate the selected cases, the model that was used was Meteorological Research Institute, or abbreviated MRI model, which was developed by Japan Meteorological Agency. Two major factors are considered for calculation of storm surge in this model. They are inverse barometer effect and the wind setup. For simulation, 5 storm surge events were selected for the study. They are Cyclone Bulbul, which occurred in 2019, Cyclone Foni, which also occurred in 2019, Cyclone Mora, which occurred in 2017, Cyclone Ruaru, which occurred in 2016, and Cyclone Komen, which occurred in 2015. The MRI model is based on two basic equations. They are the momentum equation and the continuity of mass equation. Here we can see the momentum equations and the continuity of mass equation that are used for the model. Next, we can see a figure of how the storm surge model works, where we input the NWP model data, and from there the model simulates and gives us products such as storm surge map and time series. For data use, for the validation of the model, I collected mainly two types of data. Firstly, I collected data from BMD, which was the reported maximum storm surge height data for all 5 selected storm surge events. Secondly, I collected observed data from BIWTA, Bangladesh Inland Water Transport Authority, and from them I collected the cyclone Bulbul data, which was only available, which was the strong tide data, and it was the hourly data. Next, for simulation, I used two types of data, which are NWP ECMWF model data and MWP GSM model data. Both had resolution of 0.25D. Using both the data, the model ran for 4 hours and simulated the 5 selected storm surge events. After simulation, the selected events of using both the data sets, the results were visualized using graphs. For validation of the model, firstly, the simulated results of Cyclone Bulbul was compared with observed data collected from BIWTA, and then using Python programming language, a time series graph was developed. Further, the reported maximum storm surge height data, which was collected from BMD, was compared with the simulated data of all 5 selected cases. Next, we can see the results and analysis of the research. Here we can see the Cyclone Bulbul, which was at the right side. We can see the visualization from NWP ECMWF data, and on the right side we can see the visualization using NWP GCM data. For Cyclone Bulbul, the highest storm surge height was on 9th November 12 UTC. And for NWP GCM data, Cyclone Bulbul had the highest storm surge height at 9th November 14 UTC. Next, Cyclone Phony. Similarly, we can see at the left side the visualization using NWP ECMWF data, and on the right side we can see visualization using NWP GSM data. For Cyclone Phony, for NWP ECMWF data, the highest storm surge height was shown at 04 UTC on 1st May 2019. And for NWP GSM data, for Cyclone Phony, the highest storm surge height was shown at 09 UTC at 1st May 2019. For Cyclone Mora, the highest storm surge height was shown at 22 UTC at 29th May 2017. And for Cyclone Mora, we can see that the highest storm surge height was shown at 30th May 2017 at 02 UTC. For Cyclone Roanu, both the dataset shows that the maximum storm surge height was at 21st May 2016 at 12 UTC. Next, for Cyclone Cohen, we can see that for ECMWF data, the maximum storm surge height was at 30th July 2015 at 15 UTC. And for Cyclone Cohen, NWP GSM data shows that the maximum storm surge height was at 30th July 10th UTC. Next is the data comparison. Firstly, this graph shows the time series which was developed using Python, and this shows the MSLP or mean sea level pressure of Cyclone Bulbul. Here we can see that the ECMWF data shows lower MSLP compared to NWP GCM data. Next, there is a time series showing the zonal wind of Cyclone Bulbul. This was also developed using Python programming language. Next, there is a time series of meridional wind of Cyclone Bulbul, which was also developed using Python programming language. Here we can see that the NWP ECMWF data shows higher wind speed compared to NWP GCM data. Next is the time series of storm surge height, where the observed data collected from BIWTA was compared with both the simulated results. And this graph shows that the ECMWF data was relatively closer to the observed data compared to the NWP GSM data. Next is the table which tabulates all the 5 events and all the maximum storm surge height that was simulated for both the data sets and also the reported data that was collected from BMT. And here we can see the graph which shows that the comparison between the reported and the simulated data for maximum storm surge height. Now, here we can see that for Cyclone Bulbul, the NWP CMWF data slightly underestimates compared to the reported data. And for NWP GSM data, it underestimates compared to the reported data. For Cyclone Phony, we can see that both the data sets are less compared to the reported data. For Cyclone Mora, we can see that the NWP SMWF data underestimates compared to the reported data, and for NWP GSM data, it slightly underestimates compared to the reported data. For Cyclone Ruanu, the NWP SMWF data slightly underestimates compared to the reported data, while for NWP GSM data, it is less compared to the reported data. However, for Cyclone Komen, the NWP ECMWF data is overestimates slightly compared to the reported data. And for NWP GSM data, it is a bit more overestimated compared to the reported data. Next, I calculated the RMSE or root mean square error for reported maximum storm surge heights of both the simulated results. And here we can see that for NWP ECMWF model data, the RMSE was 0.495, and for NWP GSM data, the RMSE was 0.705, which tells us that the NWP ECMWF data was able to simulate the events more accurately compared to the NWP GSM data. Now, conclusion. The MRI model was able to simulate the storm surge height, the mean sea level pressure, and wind of all the selected events. For Cyclone Bulbul, the simulated data of storm surge height for both data sets were satisfactory results compared to the observed data. And in case of maximum storm surge height for both the data sets, the simulated results were close and a little bit underestimates or overestimates compared to the reported data. So overall, we can say that the results of the MRI model simulation of the selected cases are satisfactory, and the model can be used for future storm surge forecasting. However, this model may be coupled with other models such as WRF model to improve the simulation. Further, the study of the sensitivity of model resolution remains a significant future scope for the present work. So there is a need for further study of all other different cases like Amphan and other cases that are occurring, and also the future cases to improve this model even more. Lastly, I am to thank Bangladesh Meteorological Department, Dhaka, Bangladesh, for providing the necessary meteorological data and for the assistance with installing MRI model and providing all the NWP model data that was necessary for the simulation. Thank you everyone for your patience. And now you can, if you have any question, please ask me.
Well, thank you for your presentation. I think considering your background as a student, you have done a fairly good work. Storm surge is a operational issue for Bangladesh as well as for India, and using state-of-art models, you have tried to validate them with the data. So it's a good initiative. And as you write about, we need to work more using WRF and high resolution data model to see it. My only question was that you have not in your conclusion mentioned about use of ECMWF data. How you have shown the results of ECMWF doing better than the other global model, but how do you see that in predicting the storm surge and its use in Bangladesh?
Thank you, sir, for your question. I think, sir, ECMW is the European Center for Medium Range Forecasting Data, and this data is better compared to the GSM data that I used. So ECMW data can be used for better prediction compared to the NWP GSM data. There was one case where GSM data showed better results than ECMW data. So I think further study will prove that whether ECMWF data is better actually than GSM data. Thank you, sir.
And how do you use this data into your MRI model, and how do you plan to use it in WRF? So what is your plan of action?
So for further research, I think simulation of the cyclones using WRF model, then taking the data from WRF model and inputting them in the MRI model, and then comparing them with the MWP ECMWF data, the results from the MWP ECMWF data, and from the NWP GSM data, the results that I got. Then when after the comparison, we can say that how WRF model compares compared to the NWP GSM data and NWP ECMWF data.
Okay, thank you so much.
Thank you, sir.
We have got some time for some couple of questions. So I request audience and participants to put this questions, their questions for this presentation and maybe for other presentations also.
Can I ask a question?
Please.
How heat waves are defined in India?
Okay. Well, in India, the heat waves are defined for the plain stations, for the hill stations. There are different thresholds. Essentially, they are from the departure normal. Maximum temperature, how much the departure on a given day is there, and there are two categories of heat wave and severe heat wave. If departure is 6.5 degrees centigrade or less, then it is normal heat wave, otherwise it is severe. And if temperature is more than 45 degrees centigrade, irrespective of the normal temperature, it is called severe heat wave. For coastal areas, the thresholds are lower. 35 degrees centigrade and above can be considered, but for the plain stations, it is 40 degrees centigrade and above. So, but then what we find is that thresholds have to be determined. They are not universal. And particularly the humidity, the coastal stations, the thresholds needs to be considered, and human factor needs to be, we can't use the indices which have been developed in the European countries or the United States. See, adaptability to the temperatures and humidity is much different than what is happening in Europe or in other Western countries. So we have to develop our own thermal index based on the large amount of data, and then only we should be able to bring out thresholds for the heat wave definition correctly. So a lot of work is going on. The percentile data, 90 percentile data is one way of looking at, but then the real data will be if we have a computed thermal index based on our own data. But yes, I'm happy that countries are now started working and developing some indices for their region.
As far as I know, IMD conducted a comprehensive study of temperature variations over the India. and the person named maybe R.C. Steedman and A. Choudhury is there. And IMD has a publication, maybe publication number 16 like that, on temperatures over India. But I never found that book, sorry to say. But you are right that for place to place, even small countries like Bangladesh, the sensation of temperature to human body differs between a wide range. So we have to if we want to define apparent temperature for operational use, we have to go very cautiously. Say in Bangladesh, in Rajshahi, in the month of May, on April or May, the average temperature may be 37 or like that, the maximum average of maximum temperature. But in the meantime, at that period, at Dhaka or Chittagong, the temperature is much lower. So the people who are living continuously for several years over these areas, the sensation of temperature for their bodies is very different. So we cannot impose any comfort index for every part of the country. It is very difficult to understand for people or conceive by other communities living in different parts. So the people who are working with heat waves, they should consider physiological effects, clothing pattern, culture, etc. So thank you very much. I enjoyed the lecture by Professor Akhtar.
have a regional applications. Yes, yes, I totally entirely agree with you that within the country also, like Bangladesh, it cannot be a single threshold for the heat waves. I totally entirely agree with you that within the country also, like Bangladesh.
এই রায়হান কি প্রবলেম হচ্ছে?
Any issue, Tyagi sir?
Yeah, please go ahead.
Yeah, I think I would request others who are not speaking to mute themselves.
Okay, am I audible?
Yes, sir, you are audible.
Okay, so I think now it's time for us to conclude. We had 4 presentations by speakers from the senior professor Takami to young researcher. So it's and also covered almost all important aspects of severe weather which affects Bangladesh and adjoining countries. That is cyclone in emerging climate change scenarios with heavy rainfall downscale to the urban areas by Professor Takami, followed by the lightning potential, which is so important, the nor'westers and the thunderstorms forecasting, and then coming to the 2 to 3 hours in advance, if we are able to, using the lightning potential, are able to predict the lightning. Only thing is that they are based on limited studies, but good start. And surely with the validation data now available, more number of studies will be able to come out with some good results. And similarly, the heat wave, there are two things. One is the prediction of heat wave, and second is the determining the thresholds or the heat indices for our region. So these are two things which are related, but they can be done independently also. Because if we have got data of temperature and humidity and human comfort, then we should be able to develop our thresholds or the indices for the region. Surely we cannot use what is being indices being used in Europe or United States. There are a number of work in India we have done it. We find that those indices are of no good for our region. And the last, I think, good effort to study the storm surge using MRI model and also initiating with the. So in all, I think from my side, I'm very happy to see good presentations being made. And I'm sure this will pave way for more work in the region. This is a good start push in these four important areas. And I now request my co-chair to give his views, because he is the person who is closely related to on the ground with the labs to use such products and provide capacity to the countries in the region. So
thank you very much, sir. Actually, we first start from Dr. Takemi. I think this kind of research is a bridge between disaster risk reduction and climate change adaptation. When we actually talk about climate change, we usually try to look at longer terms, but sometimes we ignore what are the impacts at the intermediate scale. So in that term, Dr. Takemi's work is very useful, and I think we also need to conduct similar studies in Bangladesh. For our second presenter, Dr. Mullik, I think this could be very much useful if we are able to validate more events, and I think we can further discuss with BMD how we can operationalize a system so that this because you have made several observations about some thresholds. So how we can customize this for Bangladesh, and in our operational day-to-day forecasting, how we can generate these indices. And as Dr. Tiagi sir mentioned, now there are various sources where we can get the data, observed data. So how we can validate and also examine the accuracy of these indices, so that this could be used for operational early warning system. And you rightly mentioned that government of Bangladesh has recognized lightning as a major hazard a couple of years ago. So I think this initiative and further research on this will certainly contribute this in this sector. And for Dr. Akhtar, I have already mentioned that similar effort is needed. I think a heat wave is something that is kind of sometimes overlooked in Bangladesh, and is sometimes the casualties are unnoticed. So if we can develop something, but as Dr. Sadikul also mentioned, that we need to consider the local culture. Actually, we need to consider the human layer here, and also customize the index equation for Bangladesh. And I also would like to mention, because I am working with the Department of Livestock Services and the other livestock related stakeholders. This heat index or the temperature humidity indices, these are very much crucial for livestock sector too. So if you want to make decisions in the livestock sector based on weather forecast, so these kind of indices also need to be developed for the livestock sector. So I think in future maybe you can also collaborate with our livestock colleagues and see how besides the human, how this can also be applied for the livestock. And for our last presenter, Mr. Faisal, very promising young researcher, and I have just one suggestion for him because the study he currently made, we can clearly see that for cyclone Phony, it could be a special case because both of the models actually underestimated cyclone Phony. So perhaps in future he can exclusively have some research on cyclone Phony and try to find out more if there was any special case here. And last but not least, I think all the four presentations were very much relevant, and I think I thank you Dhaka University for organizing this. And having said that, I just hand over the floor to Dr. Tyagi. Thank you.
Thank you so much, Dr. Ainul Khan Sahib, and all the presenters. I would like to compliment. In fact, I personally benefited a lot about the new work which is going on in Bangladesh, and also our contribution from Professor Takami in Japan, which is so important in climate change scenario. I'm thankful to organizers for giving this opportunity to me to chair this session. And I'm sure the discussions done here and the recommendations or whatever the comments have been made, I will benefit the presenters and also will give a push to the research in these four important areas. What I liked about is that all these four are the emerging areas of the severe weather problems, and they are being addressed. So though it is a beginning, but then it's a very good beginning, and I am sure in coming years it will positively yield good results. So with this, I thank organizers and give the floor back to the organizers to conclude this session. Thank you.
Thank you, Honorable Chair and Co-Chair, for conducting the session and all the participants for their amazing presentation. And I would also like to thank all the audience to attend this session. Our next technical session of the conference will be start at 20:15 in Bangladesh Standard Time. So all are invited to join the session. Thank you, everyone.